going to talk about parent functions and transformations. This is from section 1.5. And most of these parent functions you should have already seen, I'm sure. But let's go ahead and go through them. So we have the constant function first, f of x equals c. Now, c is just a real number. It is any real number, could be -5, could be positive 1 million plus pi, any kind of real number. It's just going to give you that horizontal line. Like for mine right here, I would say this is y equals 3.5. Because when we say f of x, you can also think of that as y. So you can say f of x equals 3.5, or you can say y equals 3.5. The identity function the output is the same as the input. So if I put in 1 for x, well, guess what? What is y? What is f of x, in other words? It's going to be 1. If I plug in 3, I get 3. If I plug in -3, I get -3. That's why they call it the identity function. Quadratic function. So f of x equals x squared. Just a little review here. So this is an even function. I know that it's even because it's symmetrical about the y-axis. And if you remember the algebraic rule, I know that f of x equals f of negative x. Negative x, if I square it, so that's negative x times negative x equals positive x. So this is even. Cubic function. So this would be x to the third. This is an odd function. It is symmetrical with respect to the origin. And algebraically, I would say negative f of x, so that's negative x cubed, equals f of negative x. So that'd be negative x in parentheses. Again, just a little review here. So if I say f of negative x, I mean the negative x is in parentheses. This over here was just negative x cubed. Of course, negative x times itself 3 different times will get you the same thing as negative x cubed. Square root function. So this is the square root function. I didn't necessarily draw this one to scale. I probably should have. But it looks something like this. Notice the restrictions on the domain and the range. It's all positive. Domain is all positive reals. The range is all positive reals. And that simply goes back to the fact that I can't have a square root of a negative number. Because, we're not going to do complex numbers right now. Later on, we'll do complex numbers. But for now, we're just going to worry about the real numbers. And so as far as the real numbers are concerned, you can't take the square root of a negative number. Reciprocal function is f of x equals 1 over x. Notice the end behavior here and what happens in the middle. So let's start with the middle first. They should have a term called middle behavior. That's when all the interesting things happen. In the middle, notice this is going up here, this is going down here. That's simply because you cannot divide by a 0. Anytime you divide by 0, you get undefined. So if I look here at x equals 0, there is no y value because it's undefined. So, and also, if x was super, super, super tiny, you end up getting a very large number. Because remember how fractions work. If you keep the numerator the same and you make the denominator smaller, the number gets bigger. That's why it goes towards infinity. In fact, if I could say that the limit as x approaches 0 from the right side equals infinity. Now, the limit from the left side as x approaches 0 would be negative infinity. I can also talk about end behavior. The left end behavior is going to be 0. This tends to 0. And the right end behavior is the same way. It's going to go to 0. Now, they're going to 0 from opposite sides, but the point is, when you talk about limits, we really care about where are they heading. Both of these are getting closer and closer to 0. All right, so let me to the next page here. So 2 more parent functions, and then I'll talk about transformations. First up is the absolute value function. F of x equals absolute value of x. Hopefully you're familiar with this, but just in case, absolute value means that whatever's inside, you make it a positive. So if I have absolute value of -5, that's going to become positive 5. If I have absolute value of positive 5, I just keep it the same. It's still going to be 5. Over here, I have the greatest integer floor function. So your book calls it the greatest integer function. I'm used to calling it the floor function because we also have something called the ceiling function. Y'all don't have to worry about the ceiling function. The only thing they ask you to worry about is the floor function. So we're just going to stick with that one. And you can write it either way. Your book writes it like this, because again, they only talk about the floor function. They don't have to differentiate between floor or ceiling. Everywhere else, we write it like this. This would be the floor function. Ceiling function would look like this. You would have like, I'll write that just a little bit darker. It looks something like this. That would be the ceiling, but you don't have to worry about that. So don't even write that down. I don't want to add more to what you have to do. Here's some examples here. So if I have the floor function of 2.2, it's just going to be 2. What about 2.7? Well, that's still going to be 2. Think of it as always rounding down. You're always going to round down for the floor function or greatest integer function. This name is a little confusing. It says greatest integer, but really what you're doing is rounding down. Now, if you get to the negatives, it might get a little confusing. Look at negative 2.2. Well, if I round that down, remember, the bigger the negative, the smaller the number. So if I go over here, look at the graph. Negative 2.2 is out here, but where does it hit for f of x? It says f of x is negative 3. So be careful on those negatives. All right, so vertical and horizontal translations. So these are types of transformations. Let's look at vertical first. This is the easiest one. G of x equals f of x plus k. So if you have a function and you just simply add or subtract something at the end, that means you're shifting it up or down. If you're adding something, so k is greater than 0, you shift it up. If you're subtracting something, you shift it down. So I just used an example with the quadratic, f of x equals x squared. So this guy up here, I could say x squared plus 3 because it's shifted up by 3. This one down here shifts down by 3. So I say f of x equals x squared minus 3. So this is x squared minus 3. I'm subtracting 3 at the end. That means I just shift down 3. Horizontal translation. So this one can be a little bit more confusing because it's kind of the opposite of what you would think. It's written as this. We have g of x equals f of x minus h. So h units to the right when h is greater than 0, h units to the left when h is less than 0. So let me show an example. That's really the best way to learn this, is just by an example. Again, my parent function is the same. It's just x squared. It's a quadratic. Now, if I shift it to the right by 4, what I have here is going to be x minus 4, all of it squared. So x minus 4 in parentheses squared. So notice I'm saying minus 4, but I'm not going to the left. I'm going to the right. That's why I say opposite. So if you're subtracting a number from just the x, not the whole thing, if I subtract 4 at the very end, I get back over here to vertical translation. So if it's just from the x, that means x minus 4, so I'm going to have to go 4 units to the right. If I'm adding 4 to just the x, I'm going to go 4 units to the left. And again, that's why I said think of the opposite. All right, last thing here. How are the graphs of f of x equals 1 over x and g of x equals 1 over x minus 4 plus 3 related? So in your book, they're going to ask this a couple different ways. First thing I want to tell you is this. If this is all they give you, suppose this thing is all they give you. If you need to know what the parent function is, just take out the numbers. If I take out the negative 4 and I take out the 3, what am I left with? I'm just left with 1 over x. So I know that 1 over x is my parent function. And let's kind of answer this question, how are they related? Well, I know that g of x, it's the graph of f of x, because that's my parent function, and it's shifted to the right by 4 because it's x minus 4. Think of the opposite. So it's not going to the left by 4, it's actually going to the right. And finally, up by 3 because I'm adding 3 at the very end. And so this is what the graph looks like originally, f of x. So that's just 1 over x. And this is our new graph, g of x, this one right here. Notice how this graph, it doesn't really change shape, it's just being shifted. So 4 to the right and up by 3.